All right, we're still in Chapter 9. Here is Section 4, problem number 15. So we're in Section 4, meaning this is going to be a proportion of two different populations that we're comparing the difference of. So let's look at this one. A local school board member randomly sampled private and public high school teachers in his district to compare the proportions, there we go, compare proportions, of the national board certified NBC teachers in the faculty. The results were, as listed there. So A, give a point estimate for the difference in the proportion of all teachers in the public schools and the proportion of all teachers in private schools who are national board certified. So our point estimate for this difference, we'll be looking at we'll use our P1 hat minus P2 hat, our proportion difference. We'll do the private schools being 1 and the public schools being 2. Use that consistently throughout the problem here. So our point estimate for here, we have 0.175 for P hat 1 minus 0.150 for P hat 2. So that gives us 0.025 as our point estimate. All right, good start. Let's go on to B. And in B, we're looking at the 90% confidence interval. So 90% confidence interval, which means our alpha level is 0.10 for the difference based on these data. So of course we're in section 4, which means the equations, the things we'll be looking for are in section 4. So let's look at our confidence interval for difference in sample proportions. And for that we have our P1 hat minus P2 hat. Let's see, plus or minus z, since we have a large sample size, we'll be using the standard normal distribution. Large sample size on the proportions allows us to, because of the central limit theorem. So here we can do P1 hat and 1 minus P1 hat, or we've talked about that many times as Q1 is 1 minus P1 over N1 plus P2, Q2 over N2, and those are P2, Q2 hat, so the caret on top there. All right, so let's continue here. We've got our difference, which we just calculated in A, which is 0.025 plus or minus z at the alpha, 0.10 over 2, times the square root of this monster, which is 0.175 times 0.825 over N1. N1 was the sample size of 80 for the private school teachers, and for the public school teachers in 2, we have 0.15 and 0.85 over 520 for our N2. Okay, let's continue moving forward. So 0.025 plus or minus, or z at 0.10 divided by 2 is a z at 0.05. So if we look at t in the t distribution at an infinite number of degrees of freedom, that's where the t distribution converges to the standard or the cumulative normal distribution. So 0.05 for z, that gives us the, where's my number here, 1.645. And then here this will be with the multiplying a lot of that inner stuff out. This will be 0.0018 plus 0.00025 square root. So this is going to be 0.025 plus or minus 1.645 times 0.045, which is going to be 0.025 plus or minus 0.074. So when we work that out, that's minus 0.049 and 0.099 as our confidence interval. So from minus 0.49 to positive 0.099. Okay, there we have confidence interval. So C, now we're going to test at the 10% level of significance, which means our alpha here is going to be 0.10. Hypothesis that the proportion of all public school teachers who are national board certified is less than the proportion of private school teachers who are. Okay, so we're looking at if it's less, so this will be a single tail test. So we'll keep our alpha there versus if it were a two-tail test, it'd be alpha divided by 2. And so we'll be looking at the difference. So our null hypothesis, starting off with the first thing we do in hypothesis testing, is define our hypotheses. So null hypothesis is that P1 minus P2 equals 0, which is going to be our difference that we're looking at, our D0 or D naught. And in this case, P1 minus P2, so P1 is the private schools, and we're looking if the proportion of public schools is less. So the proportion of public schools, if it's a lesser number, then if we subtract the lesser number from the private schools, which is the greater number, then we should have something that's positive. So our alternative hypothesis would be that P1 hat minus P2 hat is greater than 0. In other words, that somehow it's supposed to look like a 2. The proportion of the private school is greater than the proportion of the public school, or worded as it said there in the problem, the public school is less than the private school. All right, so first we have that one. So second step, then our hypothesis testing is that we're going to look at what the test statistic is that we're going to use for this. And since we're in section 4 of chapter 9, we'll see what test statistic they have provided for us there. And in this case, for comparing a difference of sample proportions, our test statistic will be from the standard normal distribution. So I have P1 hat minus P2 hat minus the difference that we're looking to compare with, divided by the square root of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2, which we've calculated a number of these things already. So in this case, P1 minus P2, that was way back up here. So P1 minus P2, that's going to be our 0.025. Our D naught, that was back over here where we had that was 0. So minus 0 divided by this whole beast, which was that beast, which we calculated there, which turned out to be 0.045. Let's get rid of all those extra lines now. So, and I've done it again, so I've done steps 2 and 3 on the same line there. This is continued down here for 3, so our z value is going to be, when I divide 0.025 by 0.045, I get z to be 0.556. Let's give ourselves a little bit more room here. So 4 then, we'll look at our confidence interval is based on looking at the rejection region, so we're going to look at the z and our alpha at this time. So alpha at this point for this will be z of 0.10, and this looking that up in using like we did a moment ago in the standard normal, using the t-distribution table at the degrees of freedom being infinite. That's where I pull that one from. We had the z at 0.05 up above, so this is z at 0.1. So this one, if we look at that, that's 1.282. And so our confidence interval here is 1.282 to infinity. Anything greater than that is what we're looking at. So there, if we compare our z from our test statistic compared to our confidence interval, we wind up stating here that no, that our current data does not support at the 10% level of significance that public school teachers have less proportion of certified teachers. All right, so then we go to D. We're looking at what computing the p-value of this test. So essentially in the p-value, what we're looking at is how we get the z. So z of what equals the value we had up here of the, back up here, what probability value of z gives us 0.556. And that's the probability of z being greater than that value. So in the standard normal table, we have the probability of z being less than 0.556. We'll be able to look to determine that probability value by looking in the table, and that one is 0.7088. However, what we're looking at here is we're trying to find the probability of z being greater than that, because we're looking back up here. We were talking about greater than again. So in this case, we're going to have, so the probability that z is greater than 0.556 is going to equal 1 minus probability of z less than 0.556, or which is equal to 1 minus 0.7088, which is equal to 0.2912. So that p, another way we could look at this is that p-value is greater than the value of the level of significance of the test we're looking at, which is 0.1. So does not reject at that level. So we're looking for low p-values in this case, and it's a high p-value compared to that value. Okay, there we go.